Ahoy, ahoy. So, welcome back. This is the fourth chapter of our networking journey. It's been 2 weeks when I went through the book, and I remember I really, I mean, it was very massive. It was a massive weekend. So, I really just rushed through this OSI model, and it's gonna be important. So, this is basically the final stage before tomorrow too. This is the whole reason I'm doing this, because tomorrow is going to be important for me. So we will see if this will help us anyway. But so I thought I'm going to stream, I'm going to go through the OSI model, and also just look for networking troubleshooting stuff. So really, like, anything I can gather and take note of, really maybe even memorize, command line stuff, anything. Regardless how it will goes, this is still super useful. This is, since we're gonna continue with Python, right? So anything I learned, to be able to actually talk about it and being aware is super helpful. So this was definitely not a waste of detour. So regardless of how it goes, I'm glad that I took this. What else? So basically, it's been 2 weeks, right? I need to. What do I even remember without any notes? I'm gonna take down the notes. Okay, I'm gonna hide this from me, and we can only see Johnny as looking at us. And tell me, what do you know about networking? And what do I know? So from the top of my head, I'm always having this fear that I'm put on the spot, and I have a blank space. But anyway, so we have the TCP/IP model, which is Transport Control Protocol and Internet Protocol model. This is one of the models we use. This was developed as basically the internet, like basically as the internet, the engineers were creating it, and this model was basically creating it and advancing at the same time. Still we use this for hardware and everything. This is basically the practical model, if we can say this. And then it has 4 layers. On the bottom we have the link layer. This is the link layer, which is the hardware. In the link layer, and the cable is the link layer, for example, and it sends packets. You send little packets to the router, and you have something called carrier sense multiple access with collision detection. This is basically making sure that the packets you send is not gonna collide with others. Basically, they are sensing. Is there silence now? Okay, so I'm gonna start sending my packets. I'm gonna wait, and if they collapse or there's a collision, then both of them who are sending the packets, let's say, they're gonna wait like certain amount of randomly generated time, but different, so that then they can continue sending the packet. So this is very clever, and it's made in a way that you never gonna like. They are self-sufficient, let's say, like they think for themselves, if I can say that. Also, I think on the link layer we also have the MAC address, which is the media access control, I think. And the MAC address, when you create this guy, it has a MAC address. Do we even see here the MAC address? I don't think we do. But yeah, media access control, and yes, I remember, I guess, but I'm actually not sure if this is on the link layer or on the internet networking layer. This is something I don't know. So, but yeah, we can go to the internet networking layer, which is definitely, yeah, I know 100% that the carrier sense multiple access with collision detection is on the link layer, for 100% sure. And I think the next layer we have is the internet networking layer, which exists like the routers supporting this model, and not the other way around. So the routers, how they communicate. So every time you send a packet to your router, and then it sends it to another router, basically. It's like it gets the IP address, and this is very important, right? Because the IP address is on the internet working layer, and the IP address is given to you. So you have, of course, your network provider giving you an IP address. But for example, when you go to a coffee house or anything and you connect to the internet with your laptop, the network provider, or the router, I guess, there grants you a temporary IP address which you can use. And where was I? So you have you do your little things. Like now I'm talking to you guys, I'm talking to the cloud, and it sends the packets from me, like basically to the server for the YouTube server. So I have my link layer cable, it's going there into the router, and then from the router there's another cable. So I think that's the thing, there are multiple link layers. It's not going like once we get to the internet working layer there are no more link layers. I don't think it works this way. It's just for us to understand. But if we're gonna break it really down, then they are interchangeable. But anyway, yes, so my packets are in the router. What then? So the router, we have the IP address, and then the IP address is gonna be first half, I think, is the network address, and the other half is the host address. I think so. And how the routers will find, like, to send my packets to the final destination, that they don't actually know like the whole address. Like they're not gonna, like this router have no idea where it's gonna end exactly, my packets. But they're gonna take a look at the first half of the IP address, and they're gonna send it to the next router. And we can use traceroute. Can we even pull up traceroute? That would be super cool. Tracer and youtube.com. I don't think this is gonna work. See, that's perfect. See, and we can even see it here. And it's using IPv6, if I'm not mistaken. This is going on IPv6 now. So the little router, this is mine. It's going, looks at the first half, sends it there. No, it's that there's timeout. We have in this case, we have a time to kill. Time to live, TTL. So we have a fixed amount of time to live, and if it's gonna be lost, then he will try to send it to another one, or it. And basically these routers, it's just getting close. They look at the first half of the number, then it basically, they have like this map in there, like it's really crazy. Okay, I'm getting sidetracked. So it looks at the first half, it sends it to another, like, and it usually takes, so in this case, from each router, a packet as it's traveling, it's called a hop. So in my case, in order to reach YouTube, it took 9 hops. 9 hops, and 2 of these were a failure. And yeah, what else can I say? I think this, on the internet working layer, we have the DHCP, the Dynamic Host Control Protocol. Is it though? Or that's the oh shit. Yeah, see, that's my biggest problem, that I think it's not the DHCP. I don't even know. Dynamic Host Control Protocol. Definitely it's here. Okay. Anyway, tell us what you know. Tell us else what you know. So I also am aware that the routers are always working on, like, to updating their routes, like to have like if you take a router, brand new router, You connect everything, it has something which is programmed into it, but otherwise it's completely new, and it's communicating with other routers to get the best routes for each new packet, each new location. The domain name system. The domain name system is that, of course, there is an IP address for the youtube.com, and this is here. But the domain system is just for us to basically, we don't have to actually type like IP addresses, but that you have a name and it's then IP address is granted to it. And this is also super useful for everyone involved, because if there's like a network change, like let's say they move the server to another location, then the name, the domain, the DNS will stay the same, and they can just update the IP address. And I think that's, you know, that's beneficial. Then we have the transport layer. The transport layer, which is helping us to if we lose, because the internetworking layer has enough to worry about. So the transport layer makes sure that we don't lose the packets or they've tagged. So there is this little the flow control is there, and I believe so. And so the transport layer has this little thing called okay, I cannot think about anything. Yes. So you have to imagine that there are actually two transport layers on both locations. And when they're sending the packets, they're keeping them until there is an acknowledge. Exactly, that's the thing. So we are receiving as the packets, and the packets can even arrive out of order, because the internetworking layer doesn't care if these are sent. They're just sending it as like they're like trying to send as much as they can with no, and the transport layer actually pays attention, like, okay, that was the beginning, okay, that was the end for something else, and it basically creates order and sends acknowledgements that, okay, I received it. And that's the flow control. Exactly. So the flow control is that when the transport layer doesn't send enough acknowledgements, or like there is some timeout, then they stop sending new packets. They stop sending new packets, and then they figure out, okay, what went wrong. And then the flow starts again, basically. But that's the main thing which I know about transport layer, that it sends acknowledgements and making sure that we don't lose packets. And then we have the application layer, which are we are most involved, right? Like everything we use. Yeah. What do we know about the application? Yeah, of course we know. Like the HTTP protocol lives there. The IMAP, flow control. So the flow control is in the application layer, actually. So the web browser application is responsible for the flow control. Yeah, I'm not too crazy about this, to be honest. I'm not too crazy about this, but it is what it is. We will see. I mean, yeah, I feel like I don't know anything. I feel like, it's very, very little. Let's say it's very, very few. It's very rough, and I can vaguely talk about things, but you know, I don't think this is a life-changing knowledge there so far. And honestly, I would rather work on code. Yeah, this is definitely what I'm more interested about. Like to continue, really get to the object-oriented programming, but it's okay. This is one stream. We're gonna spend here like 3 hours, 4 hours. Like I don't even know where to start, to be honest. Okay, but anyway, so DHCP protocol. Dynamic host control protocol. Where is the dynamic host control protocol? Yes, see, I can tell you that the beginning is much more strong. Like the beginning, or gate, like it's I can, oh shit, I can tell you that you in the beginning you really try to learn, and then as we go further and further, the last parts are like really not there anymore. And we really have to want this, right? Like I can tell you, I can actually feel that you are already in a mindset that you're not good enough, you're not gonna make it, it's not never gonna happen, and you're gonna get demotivated and everything. And this is not, like, of course we are not the best and the most everything, but we can do, like, if we want something, we can do our absolute best, like our most, to go for it and not really think about the option of failure. But no, because I have the option for something, right? And the chance. So that's already like, the lamp is green, the race is on, you can do your absolute best. So you have here a day, I really need to prepare myself to be able to really talk about this more than what I just did now. But that's the problem. That's my other problem, is that I have absolutely no idea what is exactly like, if you know what is expected, it's so much better. Anyway, so in the networking layer, the dynamic host control protocol is at the internetworking layer. And okay, so what was the other thing? What was the other thing? When we were at the router, like this. Okay, let me just check. Yes, that's what I wanted to check. If the MAC address is also at the link layer, and it is, and absolutely it is on the link layer. Okay, cool. Cool. Host identifier. So we can pull up ChatGPT and ask what is the host identifier for IPv6 addresses. Yeah, similar. I can show you. Wait. See, it says it's this one. I'm honestly cold, so I'm gonna get something. I'm very glad that the cat is in peace. Okay, what now? So the dynamic host control protocol is on the internet networking layer. Wait. Okay, I'm actually very silly. So but here I don't get it actually, because here it also says MAC address. Sharing the air. Okay, yes, so I was right. So the IP address at the internet working layer. Oh my god. So the dynamic host configuration protocol is similar to the link layer. So that's when you get a temporary IP address. Okay, and what can we talk about the SS secure transport layer? So creepy, so creepy. So, okay, I'm here. So basically, I'm gonna go through the OSI model. Yeah, that's my main problem with all of this, like this whole networking part, because of course I'm learning it for the reason, but I have no idea if any of this gonna be, if they're even gonna even ask, because if they're not gonna ask and it's all about questions which I have no idea, I will be so disappointed. But that's the thing, like you have to avoid, you have to get comfortable with, you know, learning something which for the sake of learning. With Python, I'm not doing it specifically for one, reason, or like to impress somebody, let's say, but something like I can see that if I continue with the book, everything is building towards something that I will be able to use a coding language, which is super cool. But this is something which is, I still don't see where I'm gonna be the practical, other than knowing. Anyway, these are literally the little demons you have to fight. These are exactly the demons. So what happened last weekend when I was on the bus? Last weekend on Sunday. Sorry, no, that was on Monday. Anyway, so I found very nice mnemonics, which says all people seems to need data processing. All people seems to need data processing. So application, presentation, session, transport, network, data link, physical link. So let's give ourselves really some plan and not let ourselves, this is super important to not get carried away. So we did a little refresh. We were able to talk a little bit about, but I got so easily confused and everything, but still we can talk about some stuff. And we cleared out that the dynamic host configuration protocol is on the internetworking layer, obviously, and the MAC address is still in the link layer. This is super important also, and this is very cool that we know this. During the application layer is responsible for the flow control. The application layer is responsible for the flow control. The secure transport layer is on the transport layer. It's on top of the transport layer. And yes, flow control is definitely there. However, there was something else I remember which was important. Like offset. There was flow control and something else. Da 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 da. Yeah, fine, whatever. Anyway, so yes, so we're gonna go through the OSI model again. We're gonna really make notes for each step. And once this is done, and we can talk about the OSI model as well, then we're gonna just go on YouTube and try to look for some networking troubleshooting, like command line and everything. Networking troubleshooting. That's it. Something. This is gonna be super unscripted, so it's gonna be hopefully. Oh, this is a nice video. Anyway, so let's do it. And so we go through the OSI model, then we're gonna take a short break. So far, we have spent all of our time describing, how do I look? I'm gonna just put this here. It doesn't matter. So far, we have spent all of our time describing the 4-layer model used to design and implement the transport control protocol over internet protocols and applications that make up the internet. However, the TCP/IP model is not the only model we can use to help us understand how networks work. The other model commonly used to make sense of network design is called the Open System Interconnection model. While the TCP/IP model was designed and evolved as the TCP/IP protocols were developed, deployed, and changed, the OSI model was the result of a careful design process by many networking experts who worked to develop a general approach to networking models. In today's networked world, the OSI model and the TCP/IP model serve two different purposes. The TCP/IP model is an implementation model in that it provides the guidance for those who have built TCP/IP compatible network hardware or software. The OSI model is more of an abstract model that can be used to understand a wide range of network architectures. While TCP/IP is the most widely used network technology today, many different types of networks have been implemented and deployed over the past 50 years. And as we continue to improve and evolve networking, new implementation models may emerge. The OSI model has 7 layers instead of 4 layers of the TCP/IP model. Starting at the bottom, the layers are physical, data link, network, transport, session, presentation, and application. We will look at each layer in the OSI model in turn, starting with the physical layer. So remember, all people seems to need data processing. All people seems to need data processing. So we start with the people. The OSI physical layer deals with physical attributes of the actual wired, wireless, fiber optic, or other connections that is used to transport data across a single link. The physical layer also defines the shapes of the connectors and the type of media which can be used. Another problem solved at this layer is how to encode the bits that make up the data being sent across the medium. The bit encoding and modulation determines how fast data can be sent across the link. The OSI data link is concerned, so now we are at the data link, The OSI data link layer is concerned with how the systems using a physical link cooperate with one another. When data is broken into packets, the data link layer defines special sequences to indicate the beginning and end of each packet. The stations communicating using the physical connection are assigned addresses to allow for effective use of the media. Sometimes multiple stations are sharing the same media as on a wireless network. And the data link layer defines how those stations will share the connections with the other systems connected to the network. Most data link layers have also some form of checksum to detect or correct for errors in the transmitted data. The design problems solved in the physical and data link layers of the OSI model are addressed by the link layer of the TCP/IP model. The design problems physical are addressed by the link layer. Oh my god, I just literally read this paragraph and I couldn't tell you what I read. Like my brain is completely elsewhere. The OSI data link layer is concerned with how the systems using a physical link cooperate with one another. When data is broken into packets, the data link layer defines special sequences to indicate each packet. The OSI is concerned with how systems using physical link cooperate, concerned with how the systems cooperate with one another. Okay, so really we have to switch because we have a rough idea, as I just previously discussed. I have a rough idea about the 4 layers and how they, because I can tell you that link layer, hardware, MAC address, what else? The MAC address is definitely there, and the carrier sense multiple access with collision detection is there. But then we have the internetworking layer already, and the dynamic host control protocol is there. The IP address obviously is there. And then we have the transport layer, which is making sure the flow, where is the flow control? We don't know. Where is the flow control? Is it on the transport layer or not? But it sends acknowledgements. And then we have the application layer, and the application layer has the socket, HTTP protocol, the programming languages and everything. So, and that's application layer is super cool because this is where we're gonna be doing most of our stuff, right? We know about the application layer. But anyway, so we have 4 layers. We have roughly an idea. We can place things in a mind space. Where are they? But the link, we're gonna have to, this OSI model, I'm gonna have to like take this formula, take these 4 spaces and spread them across. So I think a good visual mind, like inner visual would be, is that you have this 4 TCP IP model, and you're gonna just draw, you break them down into even more. Like the OSI model is gonna help you even like how to support, and we're gonna get there probably. So concerned with how the systems using a physical link cooperate with one another. When data is broken into packets, the data link defines special sequences to indicate the beginning and end of each packet. The stations communicating using the physical connection are assigned addresses to allow for each The stations communicating using the physical connection are assigned addresses to allow. The stations communicating using the physical connection are assigned addresses to allow effective. The stations using the physical connections. You mean base stations, right? This is what you mean. Like routers. Sometimes multiple stations are sharing the same media. Jesus, you're interswapping, but media access control. So sometimes multiple stations are sharing the same media as on a wireless network, and the data link layer defines how those stations will share the connections with the other systems connected to the network. Sometimes multiple stations are sharing the same media. Sometimes multiple stations are less on, and the data link layer defines how those stations will share the connection with. I'm gonna have to like take this into ChatGPT, and you're gonna have to tell me what do you mean under media and what do you mean about stations. You're gonna have to explain LE5 to me what is the station here and the media. Think of a station as any device connected to. This could be your computer, phone, printer, or any other device that's part of the network. Each of these devices has a unique address, kind of like a home address, which allows them to communicate with each other over the network. The media refers to the physical means through which data is transmitted. This could be copper wires. Oh my God. So we talk about stations. Okay. So not the base stations. Not the base stations. Thank you so much. I should make a tea. Yeah, I think it's tea time. Where is my hat? Okay. All right. So we made tea. I pet the cat. So we can consider that this was our break. So we are breaking down the link layer, data link layer. So we checked with ChatGPT, and the stations are the computer, the PlayStations, and the media is the router. So this is sometimes multiple stations are sharing the same media as on a wireless network, and the data link layer defines how those stations will share the connection with other systems connected to networks. Sometimes. So on a wireless network, the computers use the same media, and the data link layer most data link layers also have some for node checksum to detect connection or errors. But didn't we actually talk that, the transport layer is gonna... Anyway. Like the internetwork layer in the TCP/IP model, the OSI network layer deals with the global assignment of routable addresses to the various systems connected to the network. So this is super nice that we actually read this out, because it deals with global assignment of routable addresses. The network layer governs how routers forward packets across multiple hops to get their source to their destination. Like the IP layer, the OSI network layer does not be error-free, and it assumes that lost data will be detected and retransmitted next layer. I'm so happy I took a day off today. Like, Jesus, that was legendary idea. Thank you, Gergely. And I just again touched the honey. The transport layer in the OSI model manages packet loss and retransmission, as well as flow control and window size. That was the word I was looking for, exactly. That was the word I was looking for. Window size. The OSI session layer handles establishing connections between applications. The session layer deals with ports so that a connecting client application can find the correct server application on a particular system. Some aspects of secure transmission are also handled in the OSI session layer. What? Deals with ports. Okay, so I think I need also an LE5 to this. No, I didn't mean it like this. Establishing connections between applications. The session layer is responsible for setting up, managing, and tearing down connections between applications running on different devices. Imagine you're making a phone call. Before you start talking, your phone needs to establish a connection with other persons. Okay, great. Handles establishing connection between applications. Yeah. In computer networking, a port is like a virtual door through which data can enter or leave a device. Applications use specific ports to communicate with each other. For example, a web server might use port 80 for regular HTTP traffic and port 443 for yes. Yeah, exactly. So we need to remember the ports, I believe. Yeah, the ports I didn't memorize at all. And this is also something we should remember. Okay, I'm not gonna react to this. I just changed my phone to do not disturb, and I still have a SMS, like some bzz, bzz. And this is our true enemy, as we all know, the distraction. So I'm not gonna react on the distraction. I'm strong. Applications use specific ports to communicate with each other. Oh. The session layer helps ensure that when a client application wants to communicate with a server application, it knows which port. Okay. Okay, I'm gonna do something about it. Literally, I don't understand why is this. I literally put to do not disturb. Okay, I know why. Because at 12:30, it sets up. I'm gonna change this. Because something is fucked up. Cool. So this is cool. The session layer makes sure that when finding the correct server application. When a client application wants to communicate with a server application on a particular system, it needs to know which application on the server to talk to. The session layer helps with this by coordinating the communication and ensuring that the data is sent to the correct application using the appropriate port. When a client application wants to communicate with a server application on a particular system, so we can already draw this map in our brain that the session layer is actually is part of the transport. So transport layer, like we have, yeah, we will see. The presentation layer focuses on how data is represented and encoded for transmission across the network. As an example, the presentation layer would describe how to encode the pixels of an image so that the receiving application can properly decode the data. The presentation layer also handles data encryption and decryption. decryption. Focuses on how data is represented and encoded for transmission across the network. As an example, the presentation layer would describe how to encode pixels of an image. The presentation layer is responsible for defining the format and structure of data before it's transmitted over the network. For example, it determines how text formatted. Okay. The presentation layer handles data encryption and decryption to ensure that confidentiality and security is transmitted information, and security of transmitted information. It may apply encryption algorithms to encode data before transmission and decrypt it upon reception. This ensures that even if the data is intercepted by unauthorized parties, it remains secure and unintelligible without the proper decryption keys. The OSI application layer is very similar to the application layer in the TCP/IP model, in that it contains the applications themselves. Some applications are client applications that initiate connections, and other applications are the server applications that respond to those connection requests. The various pairs of applications have protocol standards that define interoperability between multiple clients and multiple servers from different vendors. And I'm hot. Yeah, it sucks. Yeah, it's 1 hour. It's been just 1 hour and 15 minutes, and I'm already down. Unfortunately. It's been 1 hour, only 1 hour. And basically I peaked at 40. At 40 minutes I peak, and then then there is some like acknowledgement that I peaked. I think really it's I misunderstood what it's supposed to give me, because learning itself is just, it's not supposed. I have this feeling sometimes, and multiple times I had it during Python, that I have this big realization about something, and it sounds like I can connect the dots and I can have an internal map. And when I do this, it actually feels good, and it's usually around the peak, right? And then once oh my, and then I think there is some even like thought inside that says like, oh no, we reached the peak, it's over, it's only going down here from this. And then it slowly goes down and down and down. And yeah, it's absolutely horrible. It's absolutely horrible. But yeah, we shouldn't look for the enlightenment, let's say. We shouldn't look for, we misunderstanding how it's supposed to feel like, I think. Because if this wouldn't be work, then, everybody would do it. So, like, even just because you'd feel like you're not peaking anymore or anything, it doesn't mean that you're not supposed to go through this. So OSI model, we are actually in the OSI model, we are actually doing it, and yeah. Maybe I should go and have yoga and then go home. So the OSI application layer, very similar. It is very similar to the application layer. Very similar to the application layer in the TCP/IP model. Some are client applications that initiate connections, Oh my god, I can confuse myself in one moment. Requests. The various pairs of applications have protocol standards that define interoperability. So I think this one, this whole part, I could just move it. I don't even know why I have it here. It really doesn't make sense that I have this here. I could put everything from here to the chapter. Chapter 9, right? We can use the OSI model to provide an alternative way of the, I would say, I wouldn't say this, right? I would say that it's actually it's expanding on it. Nice. And here we can do maybe a sub page. Doom, 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 doom. Do 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 do. The TCP/IP link layer combines the physical and data link layers from the OSI model. The physical and data link layers are usually implemented in hardware. Products like internet, Wi-Fi, satellite, or fiber optic often are implemented in a network driver card that plugs into the back of the computer or router. The network driver card generally implements both the physical and the data link aspects of the connection in the hardware on the card. In most cases, the data link layers are tuned to the limitations and requirements of their corresponding physical layers. So in real systems, it is somewhat rare for a particular data link layer to be arbitrarily separated with any number of physical layers. Since it can be hard to separate the physical and data link aspects of a particular link technology, the TCP model combines them into a single layer for simplicity. I should sell my weekend shift already. Yeah. I'm gonna do I don't know why I'm even streaming about this, but this is super important. All right. This is pain. This is literally pain to go through this. Oh my god, I cannot tell you how much. Anyway, TCP IP link layer combines the physical and data link. Yeah, physical are usually implemented in hardware. Products like internet, Wi-Fi, satellite, or fiber optic are often implemented in network driver card. Blah blah blah. The network driver card generally implements both the physical and data link aspect of the connection in the hardware on the card. In most cases, the data link layers are tuned to the limitations and requirements of their corresponding physical layers. So in real systems, it is somewhat rare for a particular data link layer, what the fuck was that, to be arbitrarily paired with any number of physical layers. Since it can be hard to separate the physical and data link aspects for a particle link technology, the TCP model combines them in a single layer for simplicity. Okay. Hogy alszik a kismacska? Hogy alszik a kismacska? Combines data link and physical. Voltages, physical layer, connectors. Okay, this is very nice actually. This is very nice because we can really break it down that the link layer includes the physical and data link. So physical, voltages, frequency, speed. So yes, and data, addressing coordination. Do 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 do. One place that maps pretty clearly between the two models is the OSI network and the TCP/IP network layers. They perform the same functions of creating a globally routable address space and building routers to ensure that packets properly find their way from the source to the destination across multiple hop. Yeah, I realized when I'm trying to, yeah, I cannot hum in key for sure. Yeah, it's definitely not the same key. Anyway, so the features of the transport layer in the TCP/IP are spread across the transport and session layers of the OSI model. The OSI transport layer deals with flow control and packet retransmission, while the OSI presentation layer deals with multiple applications running on multiple ports as well as session establishment and teardown. The secure sockets layer in the TCP/IP model corresponds to the parts of the session and presentation layers in the OSI model. The features of the transport are spread across. And I just used a very shitty screenshot, right? Yes, so the presentation layer will overlap. Okay, shut up. It combines this no, we need the transport. The features of the OSI transport layer deals with flow control and packets restraint, while the OSI presentation layer deals with multiple applications running on multiple ports, as well as session establishment and teardown. The SSL, the secure sockets layer in the TCP/IP model, corresponds to the parts of session and presentation. The TCP/IP application layer combines the non-security aspects of the OSI presentation layer and the OSI application layer. While many TCP/IP applications deal with issues like encoding and decoding various types of data, the TCP/IP model does not see data formatting as a separate layer. Various data encoding and decoding technologies are used in TCP/IP applications, but TCP/IP tends to treat these capabilities as library code that applications make use of as needed. Okay, that's it. So the main difference between én leszapom magam, komolyan mondom, to the encoding parts, encoding format parts, and protocol. Encoding parts and protocol. HTTP. I guess. Conclusion: while the TCP/IP model described in this book is widely used to guide the implementation of TCP/IP networks, hardware and software, the OSI model can help us look at and compare a wide range of network architectures, ranging from openly developed networks to proprietary vendor-specific networks. So I'm gonna take the quiz. Can you guys see the quiz? No, you can't. How to do this? I ruined everything now. So I'm gonna just do this, I guess. I cannot, there's nothing now. Hello. Okay. I have absolutely no idea what's going on here. Okay, I think I screwed up something. I have no idea why is this doing this. Okay, I'm just gonna leave it like this for now. What is the primary value of the OSI network model? Analyze many different network models. I guess yes. How many layers? It has 7. Which of the OSI layers deals with the shape of connectors? It's the physical one. Which of the layers is most similar between the OSI and the TCP? It's gonna be the internetwork layer and the OSI network layer. Which layer does the TCP secure sockets layer map into the OSI? What layer does the TCP/IP secure sockets layer map in the So the secure sockets layer is sitting on top of the transport control, the transport layer. So, and I think so it has to be in the session and presentation layers. I mean, there's nothing like this anyway, so you kind of make it too easy. Why does the TCP model combine the OSI data link into a single layer? To make TCP model easier to understand. I guess so. No. Okay. I know what was the issue, because I was expanding something which was like this. Okay, whatever. So all people seems to need data processing. All people seems to need data processing. So we have the physical layer. We have physical layer, data link, session. So physical layer, we have physical layer. No, wait. Yes, processing. So we have physical layer, we have data link layer, we have network layer, which is the same as the internetworking layer. Then we have seems to need. So we have transport layer, we have session layer, we have somewhere presentation layer as well. Okay, that's the end. That's the end. So so let's go from top. Let's go from the top. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So let's have a lunch. Let's have a lunch. Let's eat, and then during eating, so as I did 2 weeks ago, I'm just gonna put some nice video and I'm gonna eat, I'm gonna watch it, so we don't stop the stream, because as we know, when we stop the stream, we are in danger of really losing track of whatever we are supposed to doing. So this is supposed to capture, you know, everything which is in focus. And we already 1 hour. I mean, it's nice that we revisited this. I just don't like that I'm moody. I'm super moody. I don't like this at all. Like this not supposed to be so frustrating. Like I know that when I'm invested, I can actually enjoy this and I can see the progress. And this is just triggers me for some reason. Like I'm not enjoying myself. And that's not a good thing. Like I'm not so happy about this.
is well understood as to how you would break it. Everyone. And welcome.
Who thought it's a good idea to do autoplay? Who thought?
So network.
Are you kidding me?
Hello friends. Hello friends.
So I found a nice little video. We don't know what is this. We don't know if it's gonna be useful though, but we will see. It is what it is, right? So I'm gonna put it here. It has so many likes. Yeah. Let's check this. Let's check. This is good thing. I think this is gonna be super nice. So. So I'm just gonna put this like this. Yeah, I have zero experience in OBS. I think I should have a separate, so keep one, like if it would be possible to have just, you know, the book, have something for the book when reading something, and have something for the video. Oh shit, I didn't mean to move this. But anyway, so let me feed the cat. I'm coming. Доброгуч.
First of all, thank you so much. We are now a family of 500. Thank you for all your support. Please keep growing this family. Today in this video, we will understand some networking basics. After my previous video on virtual private network, many of you requested me to make a similar video on other networking fundamentals. This particular video would cover all the networks basics which we encounter in our daily lives. We probably use it, but we don't know exactly what it does and how it works. So today we'll understand what is an IP, what is a switch, what is a subnet, what is a router gateway, what is firewall, DMZ, port forwarding and NAT. And we will cover this in two legs. First we will understand the components specific to a LAN, which is local area network, and then we'll move on to WAN, which is a wide area network. And we'll understand this yet again with a very relatable example of a school. So let's get started. Please subscribe to my channel and hit the bell icon. So friends, we will do a side-by-side comparison between a LAN and a school wherever possible. I'll try to correlate the concept so that you can easily understand. So what is a LAN? LAN is a local area network, which means that you will have a network, a set of devices talking to each other within a limited range. The best example of a LAN is your home network, wherein you have several laptops, mobiles, your printers connected to each other, and then you are also talking at the same time to the outside world through internet, which we'll cover later. So what is an IP first of all? So an IP is a logical address to identify or locate your specific machine on a local area network. So suppose in this case the laptop IP address is 192.168.10.20. This is a logical address. Anyone, any device which wants to talk to this particular laptop can send a message to this particular IP address. Correlating that to a school, suppose we have this particular school, and this school boundary can be considered as a LAN. It is a local area within which we have three different classes: class 10th, class 11th and class 12th, and we have various students within these classes. You can consider these students as different devices like a laptop, a printer or a mobile. Every student in every class has a unique roll number with which he or she is identified. That particular roll number can be identified as an IP address. Moving on, the next concept is a switch. What is a switch? So switch is a device which sits within your local area network and helps you talk to various devices within your local area network range. Suppose if you want to print a copy of your file onto from a printer, then you can simply send your request and switch will identify that okay, this request needs to go to this particular IP address. So switch specifically works within a closed range of a local area network. So in a school, if suppose a class 10th student wants to go and meet a student of class 12th, he has to first go to this peon and he has to take permission and tell him that I want to talk to this specific student and this is his roll number, and based on that this peon will pass on the message or allow this particular student to go and meet the student of class 12th. So a peon can be correlated to a network switch. But what if a student of this particular school wants to go and meet a student of a school next to this particular school, but that school is outside the boundaries of this particular school? In that case, this student has to go and meet the main security guard here, which is there at the main gate, main security gate, and he has to ask permission of this particular security guard, and only then he can go and meet someone outside the school boundaries. So this security guard is nothing but a router. So a router is a network device which sits between our local area network and the outside network, which is a wide area network. So suppose our mobile wants to connect to the internet, then this mobile will send request to the router, and then this router will connect to the outside internet. So to draw some analogies, IP of any machine can be a roll number of any student, a switch can be this peon, and a router can be the main security guard, which allows you to go outside the outside your school or go outside the network. But the question arises, how a machine would know whether a machine sits within the local area network or it is sitting somewhere outside the main local network? How a machine can understand that? That can be done through yet another concept which is called as subnet. So subnet is called as a subnetwork which sits within the local area network, and it is not an IP address. It might look like an IP address, but it is not. It is a set of flags which defines the overall range of a local area network. I'll tell you how. So suppose the IP address of this particular laptop is 192.168.10.20, and the IP address of this printer is 192.168.1.2. Between these two sits the subnet. So subnet for this particular local area network could be 255.255.0.0. What does this mean? These are the flags. These two 255 flags denotes that this particular local area network has a fixed range of 192.168. So any device which falls within this particular IP address range would potentially be the device in the local area network. If suppose this particular IP address matches, then these two zeros denotes the free range. There can be any number sitting in these last two categories because these are zeros. So it can be 1.2 or it can be the mobile 192.168.25.30. So subnet decides your local area network range. And if you want to correlate with a school example, then the roll number of one student and the roll number of another student we can identify whether they belong to the same school. So a student of class 10th can have a roll number like S1, which denotes the school, 10, 15.5, and the roll number of the 12th student could be S1.x2.20.9. So what would be the subnet range for this? You can identify. So this would be 255.0.0.0 because we are only comparing this first bit. If it matches with S1, that means that these two students are from the same school, and they can they can talk within this school network. So to summarize, any network device potentially needs three things: IP, subnet, and gateway. Now you will wonder, what is this gateway? Gateway is nothing but the IP address of this router. So router and gateway are one and the same thing. The IP address of the router is actually called as the network gateway. So this IP address along with this subnet and this gateway can pretty much talk to any other network device within the LAN or outside the LAN. So hope I'm clear on this concept. Now we will move on to the leg 2 of this video, wherein we'll understand some concepts on the wider area network. So let's start. So hope we are clear on leg 1, which covered the LAN concepts. Now we will move to the next leg, which will cover some concepts related to router and wider area network. So let's start. So router has basically 4 core functionalities which it has to deliver as a gateway device. First is NAT, which is network address translation. Second is DMZ, which is demilitarized zone. Third is firewall, and fourth is port forwarding. These are all interrelated. We'll understand how. So we now know that router is the gateway through which a local area device can talk to a device outside the network. But what is network address translation? The name pretty much describes it. So whatever request comes from the local area network device, the IP address of this particular device is not exposed to the internet. Router changes this network device address to a different address, which then goes on to the outside network. As you can see, the IP addresses of these network devices outside the local area network are different. These are all starts from 72.63, wherein our subnet starts from 192.168. That's why whenever any device goes outside to talk to another device via the router or the gateway, then that particular network address gets translated. So a normal flow would be a device would go to the router will request that particular data from a device in the wide area network, and then that would be sent back to the device. But what if a device which is completely isolated somewhere in the network wants to talk directly to this particular device in the local area network? That cannot happen. That's a security risk. That's why the firewall comes into picture. Firewall is nothing but a set of passive rules which are defined to enable the set standards of communication between the internal and the external network. Through this firewall, only a specific set of communications can happen, and these sort of ad hoc requests cannot. That's why if you want to allow any sort of communication through this firewall, what are the options you have? So you have two options. You can either configure a DMZ or a port forwarding. We'll understand these two concepts quickly. What is a DMZ? DMZ is demilitarized zone. Demilitarized zone is a zone created within the local area network, wherein it is specified to the router that whenever any ad hoc external network connection wants to try to establish a connection with the local area network, you simply pass on that connection to the DMZ. So if any request comes from an ad hoc device, it comes to the router, and router simply send it to this demilitarized zone. And if there is any device which is sitting here in the demilitarized zone, that device can directly talk to the device outside the firewall. But then the security of this particular DMZ and the device sitting within this DMZ is the responsibility of DMZ or that device. To correlate DMZ with a school example, we can correlate it like this. Suppose a parent or a guest wants to meet certain student in the school. He will come to this particular security guard and request for that meeting. And if there is a DMZ set up here, it would be actually a kind of a reception here. So what security guard can do? Security guard can simply ask this particular guest to go and wait in this particular reception so that the student can come here and meet the guest or the parent. Port forwarding is another mechanism through which you can allow the communication from outside network within the local area network through the firewall and the router. In the port forwarding concept, you do not create a separate DMZ. Rather, you specify exactly on which particular port of this particular device or this particular device the communication needs to happen. What is a port? Any machine which is there in the network talks to different machines through different ports. So take for example, whenever you hit a website on the browser, by default it goes to the web server default port, which is port 80. You hit a Tomcat server, it goes to default 8080. If you want to connect to an Oracle database, the default port is 1521. For every application, you need a port to communicate. So suppose this particular device wants to talk to this particular device, then in this device, there can be a designated port for which this communication can be allowed. So that can go into the firewall rules, and it can be written that whenever this particular device sends a request to this particular device within the local area network on specific port 80, then this particular communication should be allowed without stopping anything. So this is the concept of port forwarding. So just to summarize, we understood the local area network, we understood what is an IP, what is a switch, how these talk to each other. Then we also understood what is a router, what is a gateway. We also understand how we use subnet to identify whether a device sits within the network or is actually from outside the network. Then we moved on to the wider area network. We understood how firewall works, how DMZ and port forwarding are the two mechanisms with which we can allow external traffic into the internal network. We also understood how network address translation helps. So friends, I hope you liked this video and now you understand these concepts in a in a better way, please go and subscribe to my channel and hit the bell icon. Please like and share this video as much as possible and help us grow this community further. Thank you so much and keep hustling.
Did it even work? Yeah, okay. Yeah, cool. Oh. So, based on this, we should check if there's anything like any book. Yeah, I think that's pretty much it. I'm done. We went through the OSI model. Of course, I don't think it's enough, she said, but I cannot bring myself to continue. I will go into the city, have a yoga session, and maybe I can return. Yeah, I will return and do an evening session, and we're gonna go through other stuff. Okay, that's the plan.